Hello everyone and welcome to our maths tutorial. In this tutorial we're going to look at the functionality as well as the scope of application of the law of sinus and the law of cosines. In order to ensure that you understand what we teach, we recommend that you follow our examples closely, and if you don't understand something, you can just pause the video. So this particular example is one we can solve using only mathematical rules we do already know, since this triangle is a right-angled triangle. Using sinus and cosinus, we get to those results. We're not going to look closer to this, since this mathematical knowledge is precondition for this tutorial.
We can only use the sinus and cosinus if we have a right triangle. If we haven't got a right triangle, we need the law of sinus or the law of cosinus. We use the law of sinus when we have angle, side, angle, side, angle, or angle, angle, side. For the derivation of the law of sinus, we split a scalene triangle into right triangles. With our math knowledge, we know that the sinus alpha is the opposite side divided by the hypotenuse. So we can see here that the sinus alpha is the altitude c divided by the side b. So the altitude c can be sinus alpha multiplied by side b. In the other right triangle, we can see that the sinus beta is the altitude c divided by the side a. So the altitude c can be sinus beta multiplied by the side a. Now we can equalize both equations, and that's sinus alpha multiplied by side b is sinus beta multiplied by side a. That can also be a divided by sinus alpha is b divided sinus beta. If we will do this also with the sinus gamma, we'll see that it is the same, also c divided sinus gamma. So now we know why the definition of the law of sinus is a divided sinus alpha is b divided sinus beta is c divided sinus gamma. Attention, if we have short side, long side, angle, we will have two solutions.
Here we have an example on how to use the law of sinus. So let's start by pointing out all the information we already have. The side A is 70 centimeters long, side B is 40 centimeters long, and the angle beta is 19 degrees. As you see, we don't have any right angle in this particular triangle. So by inserting the known values into the formula of law of sinus, we get to this. We know that side B divided by the sinus of angle beta has to be 122.862. By reforming the second formula, we can determine angle alpha. And now that we have two angles, we can easily determine angle gamma. But since at the start we had short side, long side, and the angle leaning against the long side, we know that there are two possible solutions. We get to the second solution by changing alpha to 180 degrees minus alpha. And this would be the second solution.
But how does it look like with these triangles with a various shape? Because we can't establish a relation we would need if we apply the law of sines. In the following sequence I will show you how to solve this problem with the law of cosines. We have to ask the question how to determine every specification of a triangle with the sides only. To answer this question, we must find the relation between the three sides A, B and C and one of the angle, in this explanation alpha. How you probably might think, it is the height C. So let us determine the formula after Pythagoras' theorem. In the left partial triangle, side B is our hypotenuse, HC is the cathetus we want to figure out, and X is our imaginary second cathetus. The formula looks like that. Because both formulas are beginning with a h square, we know that the expression of the right side get the same results. By reducing the equation, you should pay attention that you consider the binomial theorem and the change of the algebraic sign. At the end, we can cross out the unnecessary x, and so we have almost a law. But we've just forgotten to involve the angle. To make the things complete, we have to replace our variable x For this we have to take the ratio cosine and replace the hypotenuse and the adjacent side with x and b. Finally, we can replace the x in our formula with the transformed ratio of cosine. If you don't want always to remember this law, just think that at the end has to be the angle which is belonging to the particular corner at the beginning. In the middle, the remaining corners appear in this way.
This last example shows us how to use the law of cosines. So let's again point out all the information we have. Side A is 70 centimeters, side B 40 centimeters and side C 55 centimeters. We don't have any angles, but all three sides. Again, we can insert the known values into the formula. And again, the whole trick is to reform these formulas, and that way we get to this. We can now easily determine all three angles. The result should look like this.
Finally, if we have three sides or two sides with an angle, in the middle we use the law of cosines. In all other cases we can use the law of sines. Hope you enjoyed and thanks for watching. Finally, if we have three sides or two sides with an angle, in the middle we use the law of cosines. In all other cases we can use the law of sines. Hope you enjoyed and thanks for watching.